Hi, everyone. My greetings to you all. As this conference can be viewed by across by the worldwide, I'm just giving without the time zone some maybe in good morning, good afternoon, and good evening. So I just want to say my greetings to you all. And myself, I am Srinivas Mantrala, and I'm currently working in Fidelity Investment as a senior manager. And I just want to walk you through the observability, the observability micro in the microservices, how we really evolved from the basic traditional and with current situation where we are. And if we empower that observability with more AI enablement tools, how we are going to leverage and what we can envision the future way of operation mechanism. That's the intent of the whole my presentation. It's basically called as AI powered observability in microservices architecture. Okay, it's beyond metrics where we started from initially, but now where we are landing now. So just let us get into the presentation. I'll go very quick on the introduction. As currently in the tradition, we used to have monolithic applications, and now we are moving to the microservices architecture. We started with the monolithic traditional monitoring approaches, basically like alerts, some set of threshold alerts to give the infrastructure health and everything. That is our start of our basic health monitoring systems, we call. Going into more microservices, distributed systems. So the traditional mechanism that we applied are nowhere able to meet the today's needs. Hence, we are transformed or evolved as we move from one technical to another evolvement. The same way the operation management has been evolving from one decade to another time span. So this is basically my intent is to say, hey, now we are in the AI era, and if we enable this observability with the AI features, how we can really make it more better. We actually, if you speak, we are already leveraging that, but still, I would really want to call out here, basically with my experience, how this observability is so important and how the AI can really help observability more in future. That's the intent of this. I would like to even see the framework that we can build upon and then practice that observability as we go on with new things coming up, and that will eventually help us a lot on ongoing. That's the intent of this whole exercise. I'll just start with my first, the evolution of observability. You know that we initially started with the traditional monitoring where in a monolithic application, as I called out before, we has to have an alerts or some sort of basic alerts. Here's a database is down or it is up, or is a basic alert system that was making basically the administrator used to get, and basically they act upon that alerts and work on. That is called the traditional monitoring. From there, we evolved into the next set, and that is very important, which I will take a little more time on. What is the basic observability? In observability, we have three main factors, the three pillars: the metrics, logs, and traces. Metrics, it gives a very high level overview of the system, the CPU usage, the threshold times, basically the response times or the error rate, the memory usages, everything of the application, the infrastructure. Basically, it's a high level. Coming to the logs, it's a granular level of the view. It more tells about the events, the basically the warning, the information messages and everything. It's more of a granular view of the system. Okay. Then we have the traces. Traces is basically how a request is traversing within the application. Is there any blockers for that? It's basically to trace the requests that are incoming to the application. So these are the three categories of applications, these categories of the data points that we used to collect to understand. And that was our initial basic observability, that we, from where the alert system we started, then we categorized into three sectors, and we started using them as our base for a very long term. The basic, these three were very long term. We've been using them. And now the initial observability is basically like you get an alert, you get a metrics or your data, you collect the data of metrics or logs and everything. And then based on that, we have to take a reactive approach. Basically, yes, what needs to be done for now? That is our trend where it used to be. Now, given this new, let us take around 5 years, maybe. I'm not, I think I'll go with 10, 7, 8 years. Once we started this cloud infrastructure coming up, we really had a more better enhanced version of the observability where the cloud platforms are really put a very good focus on this because they know that these are the very key factors for any cloud provider, that if they don't provide the infrastructure health to the consumers, they'll not be really been sustaining the market. So they really focus on the observability. They enhanced it in such a way that they take a next step, not just collecting the data, they applied some sort of pattern analysis on this to understand what is the peak time of a usage of a system, what is the low time, or what is the non what you call I can say non-working hours, what are the maintenance hours we can come. So this analysis has helped us to come with the maintenance hours, to know what is the peak hours, how to manage the resources based on that. This is the AI enhanced observability. The reason why I call this AI enhanced, they started using this data, analyzing them, and applying some thought process of what we can take a predictive approach. Like, hey, this is a time in a day, a very high peak hours are there. How we can apply a resource optimization there. What are the things that I can do in the maintenance which I should not do in the peak hours? That type of predictive analysis has helped us to know where we need to do maintenance hours, where we need to increase the resource. That is the advantage of this enhanced observability. The next one, which I want to call out, is not just manual intervention of increasing the resource and everything. Now think about if I can really make auto scaling, horizontal scaling or vertical scaling. If you remember in cloud, we have right now based on the peak hours or based on the season, like a Thanksgiving, where Amazon has a high volume of data, consumers hitting the system. They know that they need to scale out at that moment of time and they need to crunch back at the once it is done. So it's basically self-healing system. It's basically self-healing based on the data, analyzing the predictive analysis, and then applying a healing system. And that is what is so where we started from just collecting the data, which is our traditional. Now where we are is we are taking the data, applying our AI enablement, and then taking the measures without even a manual intervention. Hence, this is a real evolution of an observability. That's what I want to call from where we started, from where we are now, and where we can go more further on this. Let me go to the next slide. The three pillars. These three pillars, as I called out, the metrics, metrics, logs, and traces. As I called out, metrics, high level overview. It more talks about the CPU usages and basically it has the data related to the infrastructure. Then the logs is basically about a granular level of what are the usages and my mistake, granular usage of the information, including errors and everything. And then the other one is basically the traces, the request flow and everything. Okay, these are the basic thing. Now, if these three pillars, if we live as is, we could have not achieved where we are. We have really transformed them, these metrics and the logs, and applied more frameworks, or I can say more technical innovations are done on these three in order to see that how we can leverage, for example, metrics, CPU usages, apply the historical data, pattern recognition, so that we can know when to scale out, when to not to scale out. Logs, what type of errors are coming up, basically to see which is this will help us to know what is the frequent errors or frequent issues that are coming up and how we can really proactively take measures on it. For example, database. Many people are hitting at one time and the database is not reachable. So they can really take a proactive measures based on the logs, seeing the granular level of that information of the system. Traces, basically which features are used more frequently, how we can scale out that microservices more than the ones which are not used. So this is something, and intelligence getting applied onto these three and making them more mature. So that will help us take us more life, more smoother, because if we have issues, we are day in, day out, we cannot burn ourselves. But if we apply intelligence on this and make our life more easy, and that will help eventually the operations more simple, easy to manage. And one of the important thing about the usability is the SLOs. So I will even want to share one of my recent experience on this. Technical matter. So we know we have a technical, and when we know there's a business. Unless we map these two, there'll never be a There'll never be for example, a consensus. For example, if I want to enhance my observability with more of my knowledge, with more of my implementation, unless I get a business value out of it, I cannot really do an investment on this. So basically, what I really want to say is, unless you really correlate what your technical metrics data that capturing to the business KPIs, there will never be a buy-in for us to really invest a lot on the observability. It comes with a cost. It comes with a cost, and the cost need to be approved by the business, and the business need to see the value out of it, what we are doing here. And that value can only be correlated unless we can measure, unless we map the business KPIs with what we are doing. For example, user customer satisfaction. When I'm taking the customer satisfaction comes with the latency. Unless you have a data to really capture the latency issues in your systems, you cannot really gauge the customer satisfaction. Another one is throughput capacity. Same thing. Then the revenue per transaction. Unless you know what is the cost on revenue, cost on transaction per a participant, or for a customer, or for a business order, we cannot really assess how much our systems are used. Sometimes if the order takes a long time, it means we are not able to we cannot scale up ourselves. So this combination is very important to improve, sustain our observability, and to apply our practice on a long. We definitely need a business approval, and the business can only approve unless we show the value of what we are doing and how it can help the application and how it can help them from their sales pitch point of view, what we are doing. That's what is, for example, cloud. When they share, they will definitely tell, hey, how our observability practices are helping you. Unless then you will not able to go and make yourself as a customer to the cloud provider. In the same way, for any application, unless we have the metrics, data, and observability, all these logs properly enhanced, and how we are leveraging, and which the customer will never be able to come to our systems. That's the intent of the SLO. We really need to have a precise mapping of this business KPIs to technical metrics, logs, and everything, traces, so that we really have a good value benefit. And then only we can really sustain the practice of observability within our system. Else, it will be because it comes with a cost, and cost cannot be done without a business approach. Now, coming to the implementation framework, what I really want to call here is building a mature observability framework. It is not just an observability cannot be done just on one day. It is need to build as a building blocks. You need to start collecting the data. Then you need to apply some set of validation checks. Today, you are going to apply the observability checks like collecting the logs, collecting the metrics data, collecting the traces, and everything. Now, think about as we go on, we may build new microservices. So we need to ensure some controls to ensure that observability checks are being part of that existing development. For example, a new microservice is getting developed. If we don't ensure a sanity check on that new microservice and it's getting deployed to production, we may end up in an issue. So we need to ensure that the implementation required for observability is being applied as part of the build CI/CD pipelines. We can apply new checks like Sonar code coverage checks. That's not a basic, but logs. Basically integration testing. There are a lot of means of testing where we can ensure as a checklist these are being done. That will help us to sustain this observability practice a long term. Then coming to the intelligent analysis. Basically what I'm saying is applying the models, ML machine learning models, or you can say AI algorithms, to ensure that how we can leverage this collected data and do the predictive analysis. And then finally, AI ops, basically predictive, and based on predictive, how we can make them self-healing system. That is the basic implementation of the framework. See, progressing each layer of the pyramid builds on the capabilities below it, creating an observability practice that evolves with your organization needs. So based on our organization needs, we need to ensure that we do have everything in place and we do maintain that. And even when a new application is coming or new services are coming within the organization or build up, we need to ensure that making as a process that every developer or every business has this observability checks, and hence the team at an organization level who maintains these operations, they are really having this controls and checks so that there's no, just an example of penetration testing. If we don't have a proper metrics to ensure that a pen test mechanism is not there, then we may be prone to a vulnerability. Hence, these are some of the important things that we need to imply in our framework and then continue, and that will sustain for our practice. Some of the open source systems on observability is I have there are telemetry, there are a lot of tools here which I can list at Jepkin and everything. But one of the important tools which I like most and I've been personally using is Grafana. It really gives an excellent view of visualization of the underneath metrics logs, applies the predictive analysis. It even provides the suggestions what we can do, and it even the one of the important other the lovable factor that I for me is the dashboards. Based on the based on the user, you can really build your own dashboard. I may be interested in metrics and risk. The other person may be interested in log analysis. The other person may be. So you can build your dashboards focusing on where you are interested, and that really gives a visualization and even helping in. You can even build your own. It has its own supporting query language, and that is really a very valuable thing that helps a lot for us to even query the data that we want to assess or get fetch the historical data and everything. That's a very good. So what I really want to say from this slide is we started with this observability concept. Now we are in a stage where there's a vast amount of tools built upon, and every tool has its own capability. We just need to plug in that tool into our system based on our organization needs, customize it, and see that we have the complete system in place. So the framework that I talked about previously, that is what you really want from your observability, what you really want to capture, and how you can map that into a tool which is already like Grafana is an open source tool. You can apply it, customize it, and make your system. And then you need to practice is basically sustain that observability. The other important thing about this observability is the contextual alerting. Okay, initially we used to get a normal alerts. Hey, this is an alert and a production database is getting down. That was a basic alert you used to get in emails. Now with this new technology, at your mobile you can get it. There's something you're on. You doesn't need. People used to sit in front of the system in the traditional, like they were like a shift wise. People used to sit in front of the system watching. Now this is not required. With this new technology, we are able to get the alerts on your mobile. That's I really need to credit the technology advancement. But not only just that one. Right now, I can because I'm experiencing that. It will even suggest you what is the similar incident happened previously and what was the action done previously and how we can suggest. Say if a person who is on a on call and he got an alert saying that hey there's something happened content, he will have a provision from the alert itself to refer to the previous incident that was previously done and see how we can. This is a contextual alerting. Basically, you got an alert, but at the same time, it is giving a history of the previous alerts for you to refer. And you can even delegate to a right person who has previously worked on a similar incident. If he is available, you can even delegate that incident to that person. So for a faster resolution. This is how before it was not the case. We don't know who worked on a similar issue. But now we have a history of data and it even suggesting us, hey, there is a previous history, these are the steps are executed, and this is what we can do. And is the person available in the system? Let us go and reach the person. So it's more of faster resolution of incident. This is all helps us for faster resolution. I just want to take more, just take intelligent routing. That is also very important. We have many people in the system who are monitoring the operations. Not everyone is dedicated to all the people. There are certain set of sector people who are very privileged experience. So they will get those alerts. We can even delegate which alert to go home so that we have a proper incident management done in the right time so that the mean time to resolution, it gets reduced drastically. Before it was like 1 day, 2 days, just an example I'm giving. Now in hours, we are able to reduce in hours. This is all because how we are able to apply our intelligence on our lessons. It's basically lessons learned from previous experience. Where are our bottlenecks? Where are our improvement areas? How we can apply this AI models and into that, and so that we can make ourselves. It's more of as we go on, we'll improve. And I don't know, tomorrow it could be a mechanism where with this new robots and everything, things may be more changing. But contextual editing is basically helping you to give the history data and even provide the people whom you can delegate the request. Yeah, sorry, I went ahead before this is what is the outcome of that context reduction in the fast incident, MTR reduction, predictive accuracy. So based on the alerts, you can predict what could be the issue based on the previous history also. Then collaboration, as I just called out, there is an improved collaboration between, because you know whom to reach, you know whom to delegate. It's an increase and you are, instead of just putting on one person, you are delegating it to the right people. So concurrent issues can also be resolved with this. Now, the very important thing about this is the next phase, which I call right now. We started with traditional, then we went to this, what you call the basic observability, then we went to the enhanced version, then the self-healing. Now, think about the generative AI. Now, this is a new version. Think about in observability Grafana, I'm just thinking, if we build a chatbot and which can help us, you can question, I got an incident and I want to understand what can I do here. It is giving you, based on the previous historical data, what are steps to be done, and it even shows you some set of previous incidents so that you can really understand, apply, so that it's basically leveraging the previous historical data. Just an example. The other one is incident. You get an incident, someone logs an incident. But here, based on this generative AI, if a similar incident happen, you can really cumulatively build up a very good summary, and it can make the user to understand, hey, this could be possible, these reasons, and this is where is a major problem. So most frequently when this incident comes, this is the area of a fix must be done. So can I check that one? It basically helps to identify the root cause analysis very quicker with the summary. Basically, it brings all the incidents up together and gives a summary of what are the fixes done across and what is the common fix mostly done, so that you can really first go and attack that fix, that issue. That is basically the incident summary. And the other one is suggestion, as I said. What are the suggestions based on historical? So if we bring the generative into the system, not just AI models and everything, you will now apply the generative on the historical data, you really making more better. Even a new person who is very new to system, he doesn't need to really aware, he doesn't need to go with the KT sessions and everything. We can just say, hey, use the chatbot, get the information, and you are on your own. That is more like you're making everyone a new person and independent with all this data, because no one needs any information from a person. Everything information is in the historical. You just need to grab it, understand, and apply your thoughts. The last one is basically, as I said, observability is basically a discipline, you can say. When we build a new application within our organization, you need to ensure that the discipline is followed across in all the applications, so that we have a proper operation KPIs data being collected. And if this practice has been applied concurrently or not concurrently, or the right word is ensuring that discipline is followed consistently across within the organization, then you are really preparing yourself for a better operation management for your organization, so that your operation cost will come down drastically, because your incident management coming down the turn, your predictive analysis accuracy has been very good, everything. So your operation cost, then the cost of the quality is getting down, then that will improve a lot of thing to enhance, gives a breathing space to enhance our application more further. So hence, how an observability can make our life more smoother, because if we don't have proper operation management, hence the cost of quality can if it increases, then from a budget point of view, we may not be able to have a fund to improve our application features. Rather, we need to put more effort to retain and sustain our application existing. We are not in a position to scale up our application for the future needs. Hence, that's the reason this